So hi everyone. Today we'll be actually discussing two programs in Python programming. The first one is the Python program for calculating the GCD of the two numbers, and the second program that we'll be discussing today is to find the square root of any given number using the Newton's method. So first here we'll be looking into the code part, and then next we'll be moving on to the explanation as well as the algorithm. We'll be discussing about the each of the functions. So if you see, this is the code that I've written in the script. So basically this is the shell window. Okay, actually I have tried to run this program once. So this is the shell window. If you see here, once you open this Python ideal, here you normally have an option for new file. So you need to click on this new file, and then you get a scripting file like this where you can type multiple lines of code. So if you see here, this is the program for the GCD. So first what you're actually doing is you're defining a function called as compute GCD, where you're giving two variables x and y as an input. The next, actually what happens is it is checking if x is greater than y, and if it is yes, then the smaller number is assigned to y. If this is not correct, then the smaller number is actually assigned to x. So that is what I've written here in the comment. So this checks whether x is greater than y, and if this holds true, okay, it assigns the given value of y to the variable smaller. Otherwise it assigns the value of x. So the first step is, what you have to do is you have to define compute GCD, and in bracket you have to give x comma y. Okay, so this is the first thing you need to do in the compute GCD. So where in which you are giving a function named as compute GCD, in which there are two variables x and y. Then the second thing is you need to check the numbers that you have assigned for x and y, in that which is smaller and which is greater. The same thing I have written in the form of a code, wherein which I have mentioned as if x is greater than y, then the smaller number is y, else the smaller number is x. It is a very simple concept here. Then the next one is I am initializing GCD is equal to 1. So first I am initializing the GCD with 1 before I enter into the loop. And now this particular GCD is stored. This particular number, that is GCD is equal to 1, is stored in the GCD. Then I'm giving the range. Now I've started with the loop. Now what happens in this particular loop is that the iteration starts to take place. From what range the iteration starts, so that I have already given, because I've given the GCD is equal to 1. So what it happens is it starts the iteration process from 1. As you can see, I've mentioned here. Okay, so I'm clearly mentioned here the iteration range, it starts from 1 to smaller plus 1, means incrementing one after the other. Okay, now this loop mainly will check for the greatest common divisor in this particular range. Next, I have mentioned that if x modulus I, okay, is equal to 0 and y modulus I is equal to 0. So I'm checking if my x value and y value are equal to 0 or not. This is basically an assignment operator. And then GCD is equal to y. So here what is happening is it checks if both x and y are divisible with I without any reminder. Okay, so that is why the 0 is given. If the reminder is 0, if it is true, it updates the GCD variable with the current value of I. So once the 0 reminder is attained, it means you cannot go any further. So what happens, that value is actually updated with the current value of I, and that actually becomes your GCD. Then what happens, it returns that particular value to the GCD and the loop is completed. Now once this is done, so here there are two methods. First method is by taking the numbers 54 and 24. So I have already predefined the number 54 and 24, and then what I have done is I have given a print function which states that the GCD of number 1. So this is number 1. You should be sure that whatever number 1 you're writing, that is case sensitive, because if you have written number 1 here, the same number 1 should repeat here also. If you change this with a capital N like this, and when you run the code, it will throw you an error. For example, if we check here, see, it will throw an error stating that the name number 1 is not defined. 100% yes, because you have defined here with a small n, and here you are giving it a capital N. So again, change this to small n, sorry, and then and number 2 also. So this number is also mentioned here, and the number 2 is 24. So it is basically saying that print the GCD of 54 and 24. The GCD of 54 and 24 is, then you are using this particular command, that is compute GCD in bracket number 1 and number 2. So compute the GCD of 54 and 24. Okay, now this is the program for calculating the GCD and step-by-step explanation of each and every function. Now we'll try to run this particular code, and then we'll also try to understand this particular system with the help of an example, using the flowchart. Okay, once that is done, I'll also explain the algorithm, okay, that actually will really help you to understand this particular program in a much easier way. Okay, so now let us run this program. Okay, now here you've got the answer as the GCD of 54 and 24 as 6. Okay, now this is the basic explanation for the that is the Python program for calculating the GCD. Now let us look into the explanation part. So I've taken an example of Euclid's GCD. Now this is another method of finding the GCD. Now we use this method because it is actually much easier to understand the concept of GCD using Euclid's method. Okay, so here what I've done is I've taken two inputs. Okay, I'll just zoom it a bit, so I hope this is much clear. Okay, so here I've taken two inputs, A and B. Okay, so I've written here also there are two number of inputs, there are two numbers, basically A and B. So first it basically checks that where A is a larger number, if not it changes. So the thing should be that A should be a larger number. Okay, so if not it will exchange. So no means exchange A and B. Okay, and if it is yes, if means A is a larger number, then what happens, it checks that B is not equal to 0, because if B is 0 you need to print A, because that is the GCD. Okay, because once the B is 0 you are left out with only A, and A becomes your GCD. So that is why you see here the flow chart clearly says that first you take two input variables, and in that you are assigning two numbers to A and B, and then it checks that if A is larger number and if it holds good, then it proceeds and checks if B is equal to 0 or not, because if B becomes 0 then there's no point in going forward. So if B is 0 means it directly prints A, and that's it, that is A is your GCD. But now that is not the case in most of the time, or in our example that we have taken like 54 and 24. So what happens here is, so B is equal to 0, no, I have mentioned this here. So then what happens, then there are these three functions that you have to run. So basically here normally semicolon should be given, so I have given it here. These type of statements are known as sequential statement, because it executes one after the other. Okay, so the same flowchart is here also. I have taken two input, A and B, and then it checks if A is greater than B, that is B is smaller than A or not. If it is yes, it checks at least B is not equal to 0. If it is 0, then halt, the print A, because it is your GCD. Why? Because once the B becomes 0, then what happens? You're left out with A, and A is your GCD, but that is not in most of the cases. So what happens? B is not equal to 0, so you come to the next step, and next step what happens is, here there are three variables, G, A and B. Now I have clearly indicated here A, B and G are the variables that store exactly one value at a time. Okay, so here what happens is A, B, G are the variables that are the names for the integer boxes. Now let us take an example like A is equal to 5, B is equal to 3. Okay, so first what happens here is, before we run with the example, let me tell you what happens here. Please remember this, these are semicolons. Whenever in any of the flow chart, if like this semicolon is given, that means it is a sequential assignment, means the first this particular function is run, then it goes to the next, then it goes to the next. So that is the sequential assignment. Okay, so that's what I've mentioned here also, sequential order in which to apply the statement. Okay, and variables are basically boxes to which a name is given. Okay, now normally what happens is whatever GCD you are trying to find, okay, that is given by A modulo B. Now once you find A modulo B, whatever is the value of B, that is stored in A. Okay, and then whatever the value of G is there, what that you get in this first step, it is stored in B. Okay, then again it will check if B is equal to 0 or not. If it is equal to 0, then print A. Okay, so that is basically your GCD algorithm. Now let us see this with actually an example. So here first I've taken A is equal to 10, B is equal to 6, sorry. So first G is equal to A modulo B, semicolon is there. So now what happens here is that A becomes 6 and B is 6 and G is 4. Why? Because 10 modulo 6, okay, that is nothing but 6 ones are 6, so you're left out with a remainder 4. So your A is nothing but your B. So what is the value of B? B is your 6. So A becomes 6 because you are storing the value of B in A. So A becomes 6 here, and what is B? B is nothing but 6. Okay, and then finally what becomes the value of G? G is your 4. Okay, but once the iteration starts, what happens? A becomes 6 here. Why? Because 10 modulo 6. Okay, so what is B? B is actually 6, and that is stored in A, what I have mentioned here. One second. So here I have clearly mentioned whatever we get the value of B, that will be actually stored in A. So what is the value of B? B is 6, so that is stored in A here. Okay, this is the first thing. Then what happens to B? Whatever value you get in G, that is stored in B. So 10 modulo 6 is nothing but you get a remainder of 4, that is your G. Now where does this 4 go? 4 goes to B. So that is where this particular 4 is stored in B for the next iteration. Then what is G? G is nothing but 4. It is same. The value of G does not change. So this is the first thing. So first what you do is you find out G, that is given by A modulo B. Okay, then you store the value of B, okay, into A. So A becomes 6 because here B value is 6. Okay, so A becomes 6. Then what happens? Then the value of B is nothing but the value of G. So in the first step, what is the value of G? It is 4 because 6 ones are 6 and remainder is 4. Okay, so that particular 4 is what we have got as here the value of G, but G is being the value of G is being transferred to B here, so B becomes 4, and then what happens is G value remains the same, that whatever 4 is there, it is also the G value. Now this is the first iteration. So here again we see that B is not equal to 0, so this continues. Okay, so let us take another example and try to understand this here. So here I have taken A as 8 and then B as 6, and I have to find out what is the GCD. So the first step is that G is equal to A modulo B, A is equal to B, and B is equal to G. So the first thing what I do is A becomes 6. Why A becomes 6? What is the value of B? B is 6. So automatically, as per this particular statement that is here, B's value is 6, means A value also becomes what? 6. So the first step is done. Next, what is B? B is nothing but whatever you have got here in the G, that is here, that becomes the B. So A8 modulo 6. So 6 and 8. Okay, so 6 ones are 6. So the remainder is 2. Okay, so this remainder is actually G, and this also is stored in 2. Okay, and G automatically is 2. Now it will check, that is what I've said here, test B equal to 0. No, it is not equal to 0. So again it proceeds to the next step. Now you see A is equal to 6, B is equal to 2, and G is equal to again 2. Now what you have to do? Now you have to do is, first thing here, as I said here, G is equal to A modulo B. Okay, so again you divide it. Okay, so 2 3s are 6, so what is the value of G? G becomes 0 here. Okay, because again if you divide, okay, so you can clearly see that 2 3s are 6, so basically the remainder is 0. And what is the value of G? This is the value of G here. So what happens? The value of whatever B is equal to 2, that comes to your A. Okay, and then in this particular statement, what is the value of G? G is 0. So your B becomes 0, and automatically G is also 0. Now you go back and check if B is equal to 0. Yes, it is true, it is 0. So the iteration stops, and whatever the value of A is there, that is printed. So that is what in the starting our algorithm said. If B becomes 0, then whatever the value of A is there, that is your GCD. That is what I have mentioned here. So this is an easiest explanation to find out the GCD of any two given numbers using Python. Okay, so this is just an example. So this method is known as Euclid's method. It is one of the most easiest method to actually understand the concept of actually finding out the GCD. There are many complicated methods, but it is really very important to first understand by seeing the easiest method possible. Okay, because once you understand the easier method, the concept that is behind this particular any type of algorithm, once that becomes easier to understand, then no matter how complicated it gets as you progress into it, it becomes very much convenient for you to work on that. But if you take into consideration some complex algorithms or some complex concepts, so at the starting itself you tend to have some kind of doubts. Okay, that should not be there. Okay, so that's why I have taken an easiest example to actually try and understand this GCD concept. Okay, so this was completely on GCD. Next we'll also see how to find out the square root using the Newton's method. Okay, thank you.